Good morning all. So in the last class there was some mistake when I was explaining this object initializer. Like there was some syntax error. Like first we looked at constructors, right? So first let me show that. So suppose we have a student class and each student has multiple fields, and while initializing a student object we can take any of these fields as input. Now to do that there are various combinations, right? We can take no field as input and create a student object, or we can take one of the fields like semester as input and create a student object, or we can take all the three fields as input. So there are multiple ways in which we can create a student object and multiple ways in which we can take inputs. So to specify that we use something called constructors, right? So here I defined three kinds of constructors, but we can define more varieties of constructors. This is constructor overloading, right? So a constructor is nothing but a function with the same name as the class. Okay, here the class name is student, right? And the constructor's name is also student. So that is how you say some method is a constructor. Otherwise any method, how do we know whether there is a constructor or not? So the link between a class and a constructor is that the constructor is a method whose name is same as that of the class. Okay, and one more thing is constructor does not have any return type. All methods have return types, but constructor does not and should not have any return type, because you are just putting some initiating statements in your code. You are not returning anything. Okay, it is like I don't know, most of you would have used say startup applications in your laptop or desktop. That is, when the PC starts, these applications should open automatically, right? So this is something like that. So when an object is created, these fields should have these values by default. Okay, it's not necessary that all fields should be given some values by you, but some fields you may want to give some initial values to begin with whenever an object is created. In that case you call that particular constructor. Okay, in case you don't have any specific values, you don't even need to create a constructor. Constructor is optional. Only if you want to give specific values to specific fields when an object is created automatically, then you use a constructor. Okay, so there are different constructors that you can define. And how do you differentiate one constructor from the other? It is based on the parameters that you give. Like in this constructor we have one parameter, that is semester. In the next constructor we have three parameters, that is all the three: name, age and semester. In this constructor we don't have any input parameter, right? So you can have more constructors with more combinations of parameters. All right, now when you are creating a student, it should match with at least one of these constructor definitions. This is actually called a signature, constructor signature. So when you are creating a student in your program, it should match with one of the signatures of constructors, one of the constructor signatures. So like this is matching with the first constructor signature, right? Like this. Here first constructor is not taking any input parameters. So S1 is being created using the first constructor. S2 is also being created using the first constructor signature, whereas S3 is being created using the second constructor signature, because the second constructor is taking one argument, that is semester. Okay, so S3 is being created using the second constructor signature. S4, yeah, S4 is being created using the third constructor signature. Okay, the third constructor takes all the three arguments, and S4 matches with the third constructor signature, and they should be given in that same order. Okay, so even if the order changes or if the arguments change, it becomes a different signature. Okay, so for the same signature the arguments have to be same and the order also has to be same. Okay, so you can create an object only in those ways in which a constructor is defined. Okay, if there is no constructor, then you cannot pass any arguments. Usually an empty constructor is defined by default by the compiler itself. Okay, that is why earlier, if you remember, most of the times when we create an object from a class, this is how we used to create it. Because we never defined a constructor of our own, the compiler creates an empty constructor with empty parameters. So we could define any object of any class like this by default. Okay, yeah. So this is what we saw with respect to constructors. Then we came to object initializers. So what I said, now a student has so many different kinds of constructors. Okay, so many constructor signatures, right? This does not have any parameters, this has only one parameter, and then this has all the three parameters, and so on. But just for three fields, that is name, age and semester, we have these many varieties. In fact, just these three fields can have more varieties of constructors. I just didn't list all of them, all possible variations. But imagine if you have 5 fields or 10 fields, you will have so many combinations. It's like almost 10 factorial combinations you will have. So that is too much. You can't have 10 factorial constructors, right? So a simpler way is to give a different way of initializing an object's fields independent of how many fields it has and in which order you want to initialize them. If you are using a constructor, you need to take care of which fields you have to initialize, then you have to use that particular constructor. You can't use any other constructor. So that constructor should be available, should be defined. Okay. So we may not know which fields we will be initializing beforehand. So we may not know which kind of constructor to define, right? So rather than that, independent of the constructor signature, we should have freedom to initialize any fields of the object when it is being created. Okay. So I was showing that code last time, but there were some errors. Okay. So the error was nothing. It's quite simple. It's just some semicolons, additional semicolons that I was putting. Those should have been removed. So when you are initializing an object with values to the fields, you should not give it like this. You should remove the semicolon. Okay, and you should separate the fields with commas. You should not give semicolon at the end of the field and its value. You should give a semicolon after the closing bracket. A simpler way of visualizing it is to give all of these in one line. Okay, that's it. This is how you can initialize an object. So now it doesn't matter which fields you want to initialize and in which order you want to initialize them, because you are giving the field name and you are giving its value. This is like in some sense this is like Python dictionary, right? Or JSON parameters. You just need to give the field name and its value, field name and its value. Now it does not force you to initialize all the values at once, nor it forces you to initialize the parameters in a particular order. Okay, so that's all. So now this will work. So in student 1, in S1's case, I am initializing only age. In S2's case, I am initializing only name and semester. There are 3 fields: name, age and semester. For one student, I am taking only age. I am initializing only age. For the other student, I am initializing only name and semester. Okay, but this will work. This is an easier way to initialize objects rather than to create constructors and then thinking which constructor to use, and in that constructor in which order the fields are given as inputs to the function. You need not worry about all those things. So let me run this. Yeah, we are in the correct folder anyway. Yeah, it worked, right? So student 1's age is 17, student 2's name is Ram, and student 2's semester is 8. That's it. Okay. So this is an easier way of initializing any object values. While creating the object itself, if you know some values, you can initialize like this. Otherwise, you can give more values later. Like suppose later I came to know S1's semester, I can say it is whatever, and later I came to know S2's age, I can say it is whatever. Okay. Now I can print them. S2's age, semester. Okay. Okay, they are also printed. That's it. Fine. Yeah. So this is object initialization. All right. And then we looked at inheritance. So we said there are three main things in object-oriented programming, that is encapsulation or information hiding, right? For which we use access modifiers, like we make something private, we make something public, depending on the access we want to provide to different members of a class, right? And inheritance, that is class, subclass, right? Like if there is a vehicle, you have a car is a vehicle, or a line is an animal, right? So animal is a superclass and line is subclass. So we want to inherit some things from the superclass automatically into all the subclasses. Okay. And polymorphism we will see. So these are access modifiers, out of which we already looked at public and private. Public you anyway know. So when you make a class and its members public, those can be accessed from anywhere, not only from its children classes, it can also be accessed from other classes in the same namespace, as well as some external namespace also. Okay. So when you make something public, it is accessible from any class anywhere in that application. That's what public means. Okay. Whereas private means it is accessible only from within that class, not even its children. Okay. So when you make a member private, that member of that class is accessible only within that class, that is visible only to other members in that class. It can be methods in that class or the class itself, but no other classes, not even child classes, can see these methods or fields or members. Okay. So I think I showed an example of that as well. Encapsulation. Yeah. So here we have a class called person, and we made the attributes of this person private. This person's name and age, we made them private. Okay. Now this person's name and age will not be accessible from another class called program. So suppose if I try to access p1.name, suppose I say okay, let's see. It will give an error. Let's ignore the warnings. Let's focus on the error. You see, person.name is inaccessible due to its protection level. Okay. Because in the person class, I made name private. Suppose if I made it public, then it will be accessible. Now let me run the same code again. You see, it ran. Okay. So if you make something public, it is accessible from other classes as well, including the children class. But if you make something private, it is accessible only within this class. No other class, even its children classes, cannot access it. Okay. In this case, it is not even children class. It is not even a child class. It is some other class in some other file. Okay. So it anyway cannot access because that is private. But in this person class, what were we doing? We created a method which is public. Okay. And since all the members of this class, whether they are public or private, are visible to other members of this class, this so-called name is visible to this method. Okay. So it is through this method that I let other classes access the private variables in my class. Okay. So it is like imagine whatever, say we have lights and fans in the room. We have wires passing through the walls, and you can't access these wires. You can't directly control the current to these wires, but I provide a switch for you to control the current into these wires. Okay. So this method is like a switch. The private fields like name and age, those are like the electricity. Okay. So I won't let you touch the electricity directly. I will myself provide a switch which you can access. I will not give you access to the main board or switchboard or direct wires. You can't cut them. Suppose if I give you access to the wires, what if you cut them, right? What if you tamper with them? I don't want that possibility. So I will hide them behind the walls, but at the same time I want you to use them. Okay. So I will allow you to use them in a particular way. So the only way in which you can use them is you can switch on and off the switch through which you can let the current pass or not pass through the wires. That's all. You can't do anything else with the wires. You can't cut them. You can't destroy them. You can't see them. You don't even know which company's wires I am using. Suppose if I am a constructor and if I don't want you to know whether I am using good quality wires or bad quality wires. So all these things. So I don't want you to read or write into my variables. I only want you to use my variables, but only through the means that I give. Okay. So this is something like that. So I will only provide the method which you can use, and that method I will define. So you can only call that method. You can't change that method. You can call that method, and only through that method you use the variables which I'm using to implement my program. So these variables which are hidden, they are called implementation. So you don't want other classes to know your implementation details, which variables you are using, why you are using them, what are you doing with them. They need not know. You only give them, okay, this is the method and this is the definition of the method. This is how you need to use that method. This is exactly the meaning of API. So you will be using APIs, right? Like suppose you use ChatGPT API. Now you don't know how ChatGPT is implemented. You don't know the code behind. They will give you an API and they will give you its definition. Okay, this is the function name. These are the parameters that you can give to the function. That's it. You don't know any of its implementation details, any of its internal details. You don't know which other variables this function is calling, which other members this function is accessing inside its own class. You don't know. So that is the difference, and that is how exactly an API is used. Okay. So a method is a simple, you can think of it as a sample API. It's just an interface. So that's why it's called an interface. API is application programming interface, right? So I give you an interface to access my data and my logic, my program. So a switch is like an interface to the lights and the wires passing through the walls. Similarly, a method, public method is an interface to the private variables. Okay. So if you make something public, it is visible and accessible by all the classes. But if you make something private, it is accessible only by that single class. Okay. So these are like the two most extremes in access modifiers. So So suppose we have a range of access modifiers, then private is the most restricted and public is the most unrestricted way of accessing members of a class. Okay. In between we have a couple of things. In between we have protected and internal, and we also have something called protected internal. So let me so we mostly use private and public. That's all. Protected also we will use sometimes, and you will see some .NET developers using it, but it is not, I mean, use it as minimally as possible. Okay. Internal and protected internal you don't really use much. Okay, but I'll just explain the basics. So private means it is accessible only by self. Whatever class in which this member is defined, only by that class that member is accessible. No other class can access that member. Okay. Public means accessible by any class, by itself, by its children, by other classes which are not part of its which are not its children. Any class can access the public members. Okay. Protected means accessible only by self and children. Okay, so suppose I want something to be accessible only by myself and my child classes, then I will call it protected. Okay, and internal is applicable not on members but on class itself. So we call something as an internal class. Okay, all the others are applicable on the members, whereas internal is applicable on the class. Okay, and it is accessible by other classes in the same namespace. Okay, so what did we say? A namespace is a collection of related classes, and then an application is a collection of related namespaces. An assembly is collection of related namespaces, and application is collection of related assemblies. Okay, so when you make something public, that is accessible not only by the classes in the same namespace but also classes outside the same namespace, as long as they are within the same project. Okay, but within the same project I want some classes to be accessible only within the same namespace, then I will call them internal. Okay, and finally protected internal means it is protected or internal class. This is quite confusing, protected internal, and even if you use it in a code, it will be very confusing for other developers. So it is better not to use it at all. It is hardly used, protected internal. Okay, mostly we use private and public, and only when necessary use protected. Okay, and internal you will not need to worry about because it is necessary only when you are working on large projects. Okay, public and private we saw, protected we can see. So suppose yeah, so this presentation object we saw last time, like inheritance in the sense, suppose I have a an application like PPT, PowerPoint application, where we will be using different kinds of objects, right? It can be a table, it can be an image, it can be a shape, or it can be text. All these objects are presentation objects. So I can have a superclass called presentation object, which has some common properties which can be inherited by each of these subclasses, right? So this is how we created a class called presentation object, and each presentation object will have width and height. This is common for all presentation objects, and say copy and paste also we can do with all presentation objects. And then we have specific presentation objects or child objects like text. Text has specific attributes like font size, font style. This is specific only to the text object. It is not specific to table or image or a shape, right? So similarly, each presentation object will have some specific attributes and some common attributes. Okay. Similarly, image, for image object we have some specific attribute like crop. You can crop an image. You don't crop a table, or maybe shape can also have some crop feature if you treat it like an image kind of a thing. Okay. Anyway, so these are examples of some superclass and subclass relations. Now, all the members that are defined in the presentation object, since they are public, they are accessible by all the other classes like text and image. But suppose if I make any of these members say protected, okay, let me make it protected. Okay, now let me okay, first let me make it public back. I'll make it protected in a minute. So if you go to program.cs, suppose I say I create a new presentation object, and now you see height and width are visible in this object. Okay, now suppose I make this width protected. All right, you see now width disappeared. Width is no longer visible to the program class. All right, but suppose I create an object, a presentation object inside the text class. Okay, okay, I think I should give a different name. Let me see. Or let me say okay, suppose I define a function which says public void set width and in this I'll say width will be something. So here this function will take some parameter, let's say int width okay, width equal to width. All right, so now I created a, so let me comment this, let me delete this. I created a text object, right? And so I'll say t1 dot set width whatever 5, and we can also create another function. In another object we can say, in the image object we will create a function public int get width return width. Okay, so here we can say, so let me remove this. Image I1 equal to new image console dot write line I1 dot get width. Okay, so let us run this dot inheritance. Okay, double. Let me change this to int for the time being. Okay, let us see. Okay. Yes, this will do it only for that object. Width. Okay. Sorry. Okay. So let me copy this here. Okay. Okay, I need to check this. Again, there is some minor mistake somewhere. Okay, I'll check it and get back to you. So, but the point is, protected means it is accessible from the child classes, whereas suppose if I make it private, then it is not accessible even from the child classes. So even this should not be possible. Anyway, it will again give an error, so we will not understand whether it is giving error because it is protected or private. So I'll check and get back to you on this. Okay. Okay. One last thing, that is polymorphism. So polymorphism is like method overloading, like constructor, which you saw earlier. We saw different definitions of constructor. That is a kind of polymorphism. Same name but different definitions. Okay. Similarly, in so when you have inheritance, when you have classes and subclasses, a method which you defined in the parent class, its definition can be changed in the subclasses. So it is like same method. Here you are not actually defining a different method. So one way of saying it is, so let me see if I can copy something. Let's person. Okay, let's say let's change this to something like vehicle. Let me rename this as well. And say vehicle common attributes can be like make, that is which company made it, and price, okay. So let me make this all public for the time being because my focus is not on access modifiers now. Okay, so each vehicle has some make and price. Now suppose I have a method like say something like insurance, so there will be nothing inside this for the time being. Okay, now so let me remove all this. Now let me have another vehicle like say car, which is a subclass of vehicle. So it will anyway have make and price. Okay, and maybe we can have a method for the car which has the same name, so it will print some statement, the insurance for a car is more. Just bear with me. Now let me copy the same thing. For a, say, bike, the insurance for a bike is less. Okay, now let us see how this will okay, I can put a statement here as well. The insurance for a vehicle depends on its type. Okay, now in the main program, so vehicle v1 equal to new vehicle v1 dot insurance, so it should print that statement. Similarly, car c1 equal to new car c1 dot insurance, and bike b1 equal to new bike b1 dot insurance. Now let us see what it will print. Okay, again some mistake, huh? Insurance. Okay, just a minute. Override insurance. Let's see. Okay, vehicle.cs. Okay. Let's keep it like this. Again, something which I need to say. is virtual, not abstract. Yeah. So, so you see the method name is same, insurance, in all the three classes, but the functionality you have overridden based on the child class. In the previous case, in the constructor's case, the methods themselves are different. Okay, like the parameters are different. So when the parameters are different, the logic inside the function is different. So it's like for different functions, you are doing different things. But here, for the same function, you are doing different things based on the class which is calling that function. Okay, so you are overriding. So in this, I just gave a return statement, but I can also give a print statement. The insurance of a vehicle depends on its type. Okay, so I can also have this statement printed. So here, if you are in the main class, the same function does something. If you are in child class, a particular class like car, the same function does something else. If you are in the other class, bike, the same function does something else. So polymorphism, the word itself means many forms. Polymorphism means many forms. So the same function works in many forms depending on who is calling it. Okay, and to do that, first you have to define that function as virtual in the main class, and then you need to use the keyword override in the child classes to override that main function. Suppose if I don't use this keyword, okay, and I call this function, okay, still it is doing its thing. Yeah, if I don't write override, if I don't say this is virtual, and if I don't write override in any of these classes, okay, actually it should not override without this override keyword, but I don't know why it is still overriding. Yeah, actually you have to use this, but I don't know if it is a new version of C# or if it has become more intelligent that it is recognizing this polymorphism. But generally, we need to specify virtual keyword in the main class and override keyword in the child classes for the same method. Okay, so this is to what do we say? This is to allow us to change the functionality of the method during runtime. So that is polymorphism. Anyway, mostly inheritance is what you will be using in Unity programming. You may not encounter polymorphism much, but inheritance and public and private access modifiers these you will be using in Unity programming and many other topics that we discussed in C#. Okay, so from the next class we will get back to Unity, and we will look at some examples of where C# code is used to make some changes, and slowly you will need to, you will encounter many other new functions and classes of Unity itself. You will need to spend some time understanding them. So now you will not need to spend time in understanding the C# syntax. You will need to spend time in understanding the specific classes which come in Unity, which are inbuilt classes which are there in Unity. Okay, it is like start function or update function or translate, transform, these kind of functions which are there. Those you will need to understand, and slowly you will need to come up with some basic game of your own. That is like, if possible before minor 2, you will need to build some basic game of your own. Okay, after that we will move to AR. So before that we are sort of dealing with VR, virtual things. Then we will, once this is done, then we will move on to AR. Okay, yeah. So let's stop here.